Well, hi, good morning. Thank you so much for joining me here in my shop. This morning it is October 28th. In fact, it's the 28th all day today. So the last video ended with a flabbergasting moment for me when I discovered that the tube lineup in this radio doesn't match the schematic I've been using. These, by the way, have nothing to do with this radio. It's just some other tube things I'm doing. So that's a little bit, I don't know what's the right word, galling? It's not really galling. Disconcerting? Yeah, definitely disconcerting. How did I get this far into this radio and not realize that the tubes didn't match? Well, because the tubes did match. The ones I checked. Number 80 and the 41 output tube, they match. I just didn't bother checking the rest. So that's what we're going to do now. We're going to find out what is in here. So 6D6 here instead of a 6K7 as shown on the schematic. 6D6. I read up on this. This tube predates the 6K6. This tube had trouble. It was prone to oscillation. It wasn't a very desirable tube, I guess. So we're quick to move on from it. And plus, the not long after this vintage of radio, these grid caps began disappearing too, as the tubes didn't require them anymore. So the 6D6 came out a couple years before the 6K7. The schematic talks about a 6K7. The schematic must have come out a couple years after this was built. So this is an earlier version. This one is the I forgot now. It has an extension, Z. This is the Z version. Z version, I hope I got this right now. I had it backwards, I think. This version is the floor standing model. There's also a tabletop model, I think, which instead of a Z has an E at the end of it. If you're American, you don't know what a Z is. Z is an E, a Z. But there's no Z's in Canada. So it's all Z's here. So let's take a look at a couple more of these tubes and see what we find out here. As we'll go right after this one. So, you know, you might think it's a good idea to check these kinds of things right off the bat, and I do with the odd radio where I just get the sensation something's going on, and I would check to see that the right tubes are in and the right tubes are in the right place. But this radio came to me with the knowledge that it actually operated even as it was. So, I mean, how can you have wrong tubes if it's operating? This is a 6A, looks like 7. 6A7. Let's take a look and see what it shows on the schematic here. Okay, well, 6A7. It's a 6A7. And the 6K7 is a 6D6. And we're going to look at this next one here. 6B7. Let's find out what that is. Let's find out. Once I have you know, the shields off and all that, I'm 1 inch from putting these through the tube tester. So 2 of these have collars inside, 2 of them don't. Number wiped off of here. No, don't do this. The number appears to be wiped off. Well, that's not what I wanted to see. Looking for my magnifier, but it's not going to help anyway. What I'll have to do is find how can I know for sure what this is? First of all, it's a not an octal tube. 1, 2, 3, 4, 5, 6, 7 pins. That says something right there. The type was a 6B7. Get a photograph, or I'll have to dig a 6B7 out of my collection somehow. I'm not sure I really want to do that. Let's look at a picture of it on the internet though. Okay, I've got a picture of a 6B7 on my computer screen, and here's the one coming out of the radio, and they're essentially identical. Now there's a number of different makes of this tube, and a little bit different. Some of them have, instead of a solid metal, I assume this is the plate up here, it's a screen instead, but I think that's okay. Very good. This is a 6B7. I don't think there's any doubt. So it's only one tube in the end that's changed in this radio. And from what I read about the 6D6, it was an undesirable tube. So it could be they had so much trouble they redesigned that part of this radio and then sent it on its way, I guess. I don't know. I don't know how to explain these things exactly. Just make up stories about them. What this means then is the bulk of this radio probably matches the schematic, the layout diagram and the like as I've been finding. But in certain areas, especially right around this particular tube, this one here, things could be quite different in how they're wired. The socket is different, the whole shop. No reason for me to think these are bad tubes right now, because the radio operates. I gotta find the two fat pins. So I'm not going to test these right now. On. We'll leave the shields off. And the radio, if we operate it like this, it may just be a screamer with oscillations everywhere, or we may not notice any change at all with all the shields off. It's anybody's guess. Okay, where are we at now? So, oh my gosh, we reached coffee break time. I just came in here from drinking coffee. Well. Yeah, once again, if I could stop that alarm, I would. It's from a clock that has only 2 control buttons on it. I can't figure out how to work it. Which I think I've shown a few times. That this thing here is what you're listening to. I thought it was kind of neat because it looks like vacuum tubes there. Hey, 9:43. But the actual time is 9:50. I can't set the time on it either. It only has 2 buttons to operate this whole thing. That's why I have a 9:45 coffee break alarm in my shop. Now, usually when I'm talking about extraneous things like that, it's because I don't know what to say about the radio in front of me. And what am I going to say about it? Well, the process, my strategy was just get on with the replacement of the capacitors, and along the way I'll encounter things which will clarify what the situation is. And that's exactly what's happened. I've encountered something and I've clarified it. It's a tube here unexpectedly different from what is in the schematic. Perhaps I could hunt down, I have a couple different versions of the schematic here. Maybe I've got one that shows a 6D6. Hey, I'm going to stop and just check that out. I think it might be worth spending a little bit of time analyzing this resistor. It appears on both the schematic, of course, and on the layout diagram, but it doesn't look the same. So of particular interest is this capacitor here, which is connected to the second terminal from the bottom, and it goes to a post in the middle of this, I think they called this the capacitor board. They called it the resistor board. The board. What am I doing? I'm not going to find anything that way. Okay, let's take a look at the diagrams. 1, 2, 3, 4, 5 terminals. No doubt about it. Okay, we can start on this layout diagram. Here we are. And so those wires are coming up here towards the 41. C35. Oh, you know what? I think I gotta stop for today. I am actually doing 3 things at once here. This is one of 3 things I'm doing this morning, and my concentration is all over the map. I think I'm just going to stop right here. Why? Well, it looks like the software is frozen. Well, as it turns out, 24 hours has gone by. I left my shop. It didn't come back till now. Excuse me. So, wow. I think I gotta just stop and think about the basic approach here again before I do more. So I'm still trying to sort out the wiring in the radio in the sense that I'm trying to understand it. And the best way, of course, is to look at a schematic, and that can help you tremendously to understand it. But I keep finding things that are not matching the schematic. I could not find another schematic for this radio. I just have the one that I have. I have a couple copies of it, sort of. Looks like somebody redrew it at some point years and years ago. It's the same schematic though, same parts, same location. So what to do? I think I ended yesterday, and I'm trying to remember now, wondering about this capacitor here. And and that's the answer to that question. I don't get it. I don't get it. So I'm going to start here. Like I guess, you know, wow, I'm all over the place, aren't I? I guess I could just blindly start replacing these parts and not worry about the arrangement of the circuit. As long as I do part for part, nothing should change. And maybe in fact the radio will work better. And in that case, the assumption would be all these parts are in the right place, and there's nothing here really to even ponder. But I have a curious nature about stuff like this, and I don't like things that aren't adding up. It troubles me a lot. And that's why I feel compelled to keep working away at it, trying to sort it out. Okay, I'm starting to talk too much again. So I do have a bunch of capacitors here. These would like to go in the radio if they knew where to go. So this is a great big 0.1. I think I know what is going on with this. Let's change this one out here. Basically what I'm saying to myself is get something done, and not to worry so much about anything else. Yeah, that's kind of that's a good rule. These days you are handed so many things and told to worry about them, and a good number of them you can't do anything about it. You should not worry about things you can't do anything about. But that's the world we're in these days. This is going down to the... So if this wasn't replaced, this is an original. Somebody cut it down here. It could be for testing purposes. Cut it and have it out of the circuit and then put it back in. I don't know. But this is definitely a kind of connection I make when I replace parts. And what is this? This is a 0.1 600 volt capacitor. And I have to figure out where this is in the circuit before I put a replacement in. Most of my 0.1s are actually low voltage. Oh, that says 400 volts right on it. Hunky dory. Okay. I can go in. Okay, I'm going to install this capacitor, and I think we're going to try the radio out, because in fact what I'm going to be trying out is my antenna on this radio. Okay, got the new capacitor installed. Let's test the old guy over here. I already have him clipped in. Okay, here we go. Watching the eye, 50 volts. Oh, it opened right up. 150. Wow, that's opening right up. 250. It's very, very suspicious. Very, very suspicious. So we'll give it a moment to discharge. It's discharging right now through this machine. And then we're going to measure its actual capacitance. And that would be done, we do it on this scale. 0.001 to 0.5. This is a 0.1, so that's within the scale range. Okay, watching the eye again for when it opens. There it is there. Okay, and what are we reading here? We're on the 0.001 scale. So this would be 0.001. That's reading 0.001. Oh, wow, like there's no capacitance there. Most of the time these older capacitors show such a strong leak you can't test them. This one showed very minimal leakage. It's testing very, very low. Let's test it with another instrument here. It's testing at 1/100th of what it should be. And the other instrument is in another room at the moment. I have to run and get it. Okay. Let me you know, I'm going to get my coffee. I'm going to do a whole bunch of stuff and then come back. We'll test that capacitor. And what has happened to I've lost control of the mouse here. What? Oh my god, this video will never end unless I can find the mouse pointer. What's happened? The mouse pointer has disappeared off the screen. Oh, it's back. Crazy times in my shop. Okay, I've got the capacitor connected to this device. Here we go. Again, if the capacitor is leaky, these tests tend to go high. That's what I found. See how fast that was? 100 nanofarads. That's 0.1. Well, if I got that right, 100 nanofarads is 0.1. ESR, 8.5 ohms. Let me look at the scale again on this meter. Did I look at it wrong? So this is from, I had it on the, at least I think I had it, you know, this pointer doesn't point directly at things. Oh, okay, I'm going to turn it on doing this. 1, 2, 3, 4. Oh, you know what? I think I had it on this setting, thinking I had it on this setting, because it's kind of in the middle. So if it's on this setting, then the capacitor was aimed right at 0.1. So we had two devices now telling me the capacitor is good, and no sign of a leak, or well, minor leak. Okay, well, surprised at that, but basically this capacitor could have been left. I could have left this one in. Now, does this portend the situation with all these other similar style of capacitor? This one's color's a little different, like it's older or something. Okay, I I said I was going to run the radio because I really wanted to hear what the antenna sounds like. So let's do that for some fun. This goes here. These go back here. Let's just make sure everything is safe. Now, the deal with my antennas, in fact, my whole radio listening hobby has been accelerated by a factor of, I don't know, 1,000 or 10,000. Simply from two things. One is I got rid of these horrifying computers I now realize have been terrorizing me for 15 years with interference extraordinaire. Those two computers are gone. Even when they were in shutdown mode, which I thought was pretty much off, they were still barking out all kinds of radio interference, like just blowing everything away. So you've been watching lots of my videos, you see me testing radios, and there's interference everywhere. It was from those two computers, in particular here in my shop, the one that was here in my shop. They are gone. I have two other computers. These computers are not new. They're 12 years old. I bought them secondhand that are refurbished condition, but the amount of radio interference they're emitting is basically a zero, right? I can't detect anything. It's a complete revolution in my house and my hobby and my work here too. So and second to that huge improvement, I've acquired a different type of antenna, an active antenna, designed by ham radio operators. A couple of these floating around, two different designs, the same basic principle. You know, instead of having a long wire trying to intercept a wave of energy and get some charges moving in a long piece of wire, enough charge movement to drive a part in a radio like this, you know, the front end of a radio like this. Instead of that, this is nothing more than a square piece of metal. It's actually circuit board with copper on it, about an inch and a half square. That's the antenna. Connected right to it is a strong amplifier that has almost no, it has a very high input impedance. It's a FET transistor. Did I say transformer? Transistor. Right there, right inside the antenna. So the antenna is in a little tube, looks about like this. And that's now up on the end of a pole in my backyard on top of my deck. It's up pretty high off the ground now, all told 40 feet maybe off the main, off the real earth, you know, where the grass is that I have to cut. And the result is fantastic. I've just had fantastic results. I've been comparing it to my other crap antennas. Yes, they are crap antennas, no doubt about it. This thing has worked really well. Right across, right from way down low, bottom of the AM band and below, but there's nothing, I haven't heard anything down below it yet, to all the way up to 30 megahertz. Almost consistently, all the way along, beats my wire antenna except for one band, the 31 meter band. That's about 9 megahertz. For some reason, not so good there, and the wire antenna, probably tuned in that range, working just about the same, but not particularly better. So fantastic. Now that I've talked a lot about this antenna, I do have a picture of it on my phone. Maybe I'll get that in a few minutes and show it to you. Let's get this radio going. Jeepers, I spend a lot of time talking these days and not actually doing anything now. Is everything okay here? Should be. Let me just put some tools away before we do this. Okay. We are ready. Okay, volume's not high. There we go. Ooh, there's that hum. Again, you may or may not be able to hear it, depending upon a number of factors, but it's quite distinct here. Uh-oh. This is not good. Oh, this is unexpected. Okay, so a certain amount of me is panicking at this point. I Either I've made a mistake in installing parts, or you know what it is? I don't have the shields on the tubes. That's probably what this is. Okay, we got to shield up the tubes here. That's probably what it is. So one of the things I've learned about having antennas is you better have more than one. You better have at least two. And I'll tell you why. Let's say you have one antenna. And so you run outside and you make a change to the antenna of some sort. And you think it's going to be significant. So you run back inside. You turn on the radio. This isn't as easy as I expected. You turn on the radio, you listen to it for a little bit, then you say to yourself, is this better than it was? Did the conditions change? What's happened? Is it a different time of day now? Did I actually improve things or not? Or are they worse? And you might go band to band and you're scratching your head. There we go. If you have two antennas, and you're aware of the strength of each antenna, you know, the relative strength. So you know this guy is stronger than that guy, or maybe this one works better, whatever it might be. You have another antenna, and you run out, you make changes to one of them. Now when you come in, you can compare the one to the other, and you won't be asking yourself, oh, was that just change of conditions? You know, you'd be able to compare. And that's probably the most important thing, is having two antennas. What I was trying to do was holy smokes. Wow. Okay, that's not really on there all the way, but good enough for now. Because I may have to take it off later. Oh, that's the wrong kind I put on there. Oh no. I thought I had two that had collars and two that were open. We have three with collars. Why would they even put one on this tube? I don't know. Why would you bother putting one on an output tube? So using the two antenna technique, I've been able to, this won't fit on here. Is that what? How was that on there before? These are all the same, eh? No, this is short. This one's short. This one's long. Okay, I think I know what's going on. I think I put the short cover on the long tube. So this, knowing that you've improved your antenna, is actually not as easy as it sounds. When you actually try to do it, you're left with a lot of uncertainty. This isn't going anywhere near fitting in here. There we go. Got it, and I got it. We'll leave the cover off of this one right now. If the radio motorboats, we'll put it back on. Okay, did this work? I've got the covers back. Got the grid caps back. Okay, here we go again. The two antenna technique has really, really helped me. And now it's obvious when I compare my existing antennas with this new, it's more like a sensor than an antenna. Okay, so the motorboating is gone now. Anything else there? We have no antenna connected. Okay, let's hook up my outdoor antenna here. We'll see what happens. For instance, on the AM band, I've gone from barely able to hear two or three stations during the day to hearing 15 stations. I don't know about hearing 15 in here. Okay, so this is right from that antenna. Well, that's good. Okay. That's all we got? That's all you got? Let's put the ground on. Which band am I tuned to? Okay, treble up, volume up. Not a good sign here. What have I done? Have I done something bad to this radio? Did I hook up to got these backwards by any chance? No. That's a little better. So I was on shortwave band.
Starting tomorrow, you can get the latest COVID-19 vaccine and flu shots both at the same time. Planned and unplanned road work at Town Streetcar Network will try to help you work through all the changes coming up.
Former NHLer Adam Johnson has died. Leafs fall to the Predators in overtime again.
What's happening?
And coming up in business, the Bank of Canada says inflation is cooling. That doesn't mean they're done raising interest rates yet. We'll hear from the governor of the central bank on the new worries for policymakers.
It is time, 10:31.
Well, where's the directionality coming?
With our eyes on the drive, here's
What the heck is happening now? This radio should not exhibit any directionality. Wow, okay, so this is the radio that just... So how is this happening here? So I have this antenna hooked up. This is a thing out on my deck a long ways from here. When I rotate the radio... Yeah, like the only thing I can say is that it would have to be that there's a coil in here. This is far-fetched. That's full blast. Somebody told me that this is what happened. My radio, when I hook up the outdoor antenna, I have to turn the radio the right direction. I'd say, no, come on, what's the matter with you? Radios aren't directional, the antennas are. Just feeling the heat from the resistor on the other side here. Nothing serious there. Well, now it's not as distinct.
Even as the violence escalates, talks are ongoing between Israel and Hamas, facilitated by Qatar, to release the hostages
still there, but
in Gaza by Hamas.
A spokesperson for Qatar's Minister of Foreign Affairs spoke to CNN's Becky Anderson about how the escalation is impacting talks.
We are studying all fronts, all possibilities, all...
It's very subtle now.
On the sector, we can't even expect the hospital to be safely moved from one place to another. So the prime and the...
Is this wire acting like the antenna? You know, the interesting thing is, maybe an interesting thing is that I have this plugged into an isolation transformer. So there's no earth ground reaching the radio. At least that's true until I hook this up. Hook this up. Earth ground in place. I don't know. I don't know.
Rally to call for a ceasefire that begins at 2 p.m.
You could hear the AVC kick in pretty quick here.
Starting tomorrow, you can get the last COVID-19 vaccine flu shot, both at the same time. Our Mike LaCasse with the details.
With the weather getting colder, respiratory illnesses are on the rise. Health officials say the best way to keep yourself safe from them is to get vaccinated. Starting tomorrow, you can get a free flu shot and the latest COVID-19 vaccine, both at once. That's at local pharmacies, public health units, and your primary health care provider. Canada's Chief Medical Officer of Health, Dr. Kieran Moore, says everyone 6 months and older should get their vaccines as soon as possible, especially the elderly, immunocompromised, or those that have medical conditions, just so long as it's been at least 6 months since their last shot. Michael. More and more people realize the fragility of everything.
640.
Want to get out of the market?
This night interference. 590 barely. That's probably 740. What was causing that interference? I don't know. There still is something going on in my home. Of course, I almost never pick anything up in the high area here during the day. Okay, well, not to worry too much just yet. Radio's working. We know why there's shields on the tubes now. And I should just carry on. Carry on with what? This is just driving me nuts, this connection into this resistor here. I turn the power off before I get my fingers in there by accident. I think I'm going to take another round at trying to understand what this capacitor is here for. We look more closely at where it's connected back into the circuit here. And look a little more closely again at this. What's going on with this arrangement here? That's my plan. Okay, let's try this. Now I suspect this is going to be a little bit confusing. It's confusing for me, that's for sure. So let's start by just looking at the diagram over here and getting organized. So you can see the I'll use the mouse here. You can see the resistor over here on this side, and that's this resistor. And then you can see the this part here, this plate holding parts. That's this thing here. That should orient you. You can look for this capacitor right away. So look at the second terminal up on the resistor, and as I said before, it just shows it going to ground, completely different. My radio capacitor is coming off here and going over to this terminal here, this center terminal here. So what they've done with this part of the schematic is, if the part is shown, they've written the value. If the part is not shown, then they've written the part number at both termination points. So for instance, you see R15 written here and R15 written here. There's an R number 15 running between these two posts. And there in the radio, there it is right there. It's right there. Coming over to this post. There's another resistor running up this way, up to this post. And if we look, we will see it says R13 here. And if you look long enough, you'll find R13 written here. And so there's R13 going there. So we have a just as in the radio, resistor here, resistor there. Now, what's supposed to be here? Well, it says C29 here and it says C29 there. So there should be a capacitor between here and here. When we look on the radio, that's between here and here. There's nothing. There's no capacitor. And we're unplugged. Yes, we are unplugged. There's nothing behind here at all. There's no part hidden away behind there. But instead, there's this capacitor coming from this post, heading over here. This capacitor is a 0.05, if it's of any interest. And the capacitor here, this is C29, should be right here. Let's try to find this stuff on the schematic now. It's actually easier to find R15, R29, or I'm sorry, R13 and C29. Try to find this point. R15, R13, and 29. 15, 13, and 29. R15, R13, C29. So C29 is a 0.25. C29 is the one that's missing in the radio. Here it shows it going from this, where these two resistors meet, all the way over to the cathode, which would be not quite the same as going to the chassis. But in the radio I have, there's a capacitor going from here down to here. What has happened here? How many times have I asked myself this question with this radio? So again, the schematic only shows 3 of 4 resistances. So conceivably there's another one down here. I've been down this road a few times. Or did somebody connect that capacitor here thinking it's a ground, because it looks that way in the schematic, but on the radio there's another resistance here and then the ground, and the capacitor that they connected to this incorrect ground point is the one in question. In other words, they hooked it up to the wrong contact point. And you know what? If you didn't have that capacitor connected there, this would be a 3 resistor. It would just be 3 resistances. If you didn't have the capacitor connected to this point, there is another resistor. Let's go back down here now. So this point is grounded to the chassis. I mean, this creates a negative voltage, which you would use. Oh my gosh! It just comes to here and meets up with 2 capacitors. So the DC side of things, I don't get it. Normally these resistors, aren't they grounded at the bottom? This isn't grounded. It's grounded here. I have this terrible feeling I'm just going around and around and around in circles. Okay, let's go back to the capacitor in question then. Well, what if you didn't have this connection? And what if you hooked up, for some unknown reason, my mouse is stuck here. She's frozen. Where to go now? Went flying. There we are. And you put a capacitor from here to here. So that would be that's what exists in this radio. There is a capacitor from here to here, and there is no ground. There's no ground on this? Let's just check that. There's no obvious ground. Let's check that. And what? And what? I don't know. Let's check that. Let's check this. Check something. Okay, I'm hoping you saw most of what I was pointing at there, because I'm looking at my own screen and it shows more of the schematic than the piece you're seeing. We want to check and see if there's a ground right here. Is this ground? Well, you'd think you'd see one. I think they'd put one right in there. Oh. I have to keep telling myself, as much as it looks like mistakes have been made in the radio, they probably are not mistakes. They're probably me not getting things figured out properly. There's more to the story I don't know. It's something I've learned in life. If you see somebody who you believe is intelligent enough, do something odd that you don't understand, it's probably because they have some information you don't have. That's probably all it is. Ground. So we'll put one side on the chassis, the other side. There's the 500 ohms. The 500 ohms is in the radio, it's just not in this resistor. So, can we actually find the 500 ohms? You know what, I don't think I'm going to be able to. It looks like it goes to here. Yeah. And it looks like there's another wire, and it's going to disappear in behind here, and it's twisted up with another thing. Okay, so that, you know, that alone, that answers a whole bunch right there. Let's look at this. The whole thing has changed. That's a good thing I just did. Okay, so circuit could be the same. They just used a different kind of resistor and stuck the 500 ohm one on the end of this wire somewhere in here. So that being the case now, this is no longer tied to the second terminal up. It's actually on the third terminal up. That's too many terminals. That's I'm short-circuiting. It's short-circuiting. Let's trace the wire on here. See where it goes. So this wire got to lead to a 500 ohm resistor. No, it just goes to two capacitors. So how do I put an ohm meter on here and read 500? Am I reading it up? No, on here I'm reading it up, but not up. This wire's not really there. So they don't have a ground on the bottom, but hey. I don't get it. I am not getting it. I'm still not getting it. I am not getting it at all. So if we look up at the schematic now, and we see, yeah, so there's a wire from here that goes off to find another. Well, there's no wire. This is radically, like, I don't want to say radically different, but I did say it. It seems to be a radically different schematic. Certainly in this area. It's making me very erratic is what's happening. Oh my gosh. Well, it's getting a little long in the tooth here because I've been doing this for 2 days now. I probably got a huge amount of video I have to plow through and try to, you know, it's a I can't even finish sentences at this point. I'm really quite paralyzed. I don't know which way to turn. I don't know what to do next. Well, I'm going to leave my shop and do something else. Hey, thanks a lot for watching to this point. Yes, confusion is major here. You know, I could just replace these part for part and be done with it, and maybe along the way the hum will disappear and everything will be hunky-dory. But I have the impression the hum is coming from an error in this radio that needs to be sussed out, and I'm reticent to just like replace wrong parts if this is in the wrong place, if something like that. But so this is why I'm paralyzed. I'm paralyzed. Paralysis. Yeah, it sounds like a good title for this video. Okay, well, thanks a lot for watching. Sorry things aren't progressing so well, but it, you know, once again, it is what it is. This is all reality TV here. So thanks a lot for watching, and sorry I'm talking so much, and now I'm going to shut up. See ya.